Hello everybody. Today we are going to solve this problem from GATE 2022 easy question paper, and this is question number 13. Already I have solved this problem using nodal analysis, but now we are doing it the other way, that is using mesh analysis. Okay, let's get started. So what is asked? The electric circuit is given here. So there is a voltage source here. Here you have this 2 kilo ohm through which the current I is flowing. This is to be found out by us. Okay. So another 2 kilo ohm is here also you have 2 kilo ohm resistor. Okay, and here you have a current source of 10 power minus 3 amperes which is flowing upwards. Okay, since you have two closed path, we can form two loops. This is loop 1 with the current I here, because the I current is mentioned in the problem itself, and this can be taken as current I1. Before solving this problem, let's have a quick recap on how to solve this problem. So this is taken as case 5 in the mesh analysis, which I have explained in detail in some other video. So this consists of resistors, voltage source and the current source, two loops, and the two equations can be formed. That means two unknowns are there, right? So if you want to write the voltage equations, that means it is coming under mesh analysis. So KVL, that is Kirchhoff's voltage law, is to be applied, and we are assuming the two currents here. And see here, this current source is available at the peripheral of the circuit. Okay, so on that case, for this loop 1 we'll apply the KVL. In this we have a number of, that is 5 number of resistors, but in our problem only we have 3 number of resistors. That means it is simple when compared to this particular case. Okay, for this, we if you want to write the KVL, so we start from this point and then we travel through this path in which we encounter with this minus sign first, so it is minus V, and then we go through this in which we have this R1 resistance, but the voltage can be taken as V1, and then here it is traversing through this path in which we can take the voltage as V2, and then it is traveling through this path in which you can take the voltage as V3. And here we can apply the Ohm's law where V is equal to IR. Okay, so here already we have the magnitude, no need to apply this. This is known voltage, but this V1 is not known to us, but we know the current flowing through is taken as I1 and the resistance is R1. So this can be applied Ohm's law. So you can write it as I1 into R1. And this V2, in this V2, this R2 is common for this I1 as well as this I2 currents. Okay. So you have to write it as I1 minus I2 into this R2. Here we have applied Ohm's law for this V2. And for this V3, here this resistance R3 is involved and only this I1 current is involved. So I1 into R3, that is equal to 0. In this way, we have formed the first loop equation. Then we move on to the second loop. Whenever you have a current source like this, which is available at the peripheral, simply you can write the current value. So this is taken as I2. I2 can be taken as minus A. Why? Because this I2 is traveling downwards, but this current source is supplying current in the upward direction. Okay, so it is negative value minus K. So in that way we can solve. Here you notice that this R3 is not available in our problem. This R5 is also not available in our problem. So we'll see how to solve this. We go for this loop 1 by the KVL. So we start from here. It is minus, this is plus, isn't it? So when you start from this particular point and traveling towards this point, so we are encountering with this negative sign initially. So it is minus 5. Then the current I is flowing through this 2 kilo ohm. So in that we can apply Ohm's law, so that I can write it like plus 2 into 10 power 3, because we have kilo ohm, right? Resistance into that current I. Then we travel through this path, that means from here to here downwards through this 2 kilo ohm resistance. But in this we have both the currents available, that means I and I1. So that you can write it like plus 2 kilo ohm, that is 10 power 3, multiplied by that is difference in current, that is I minus this I1. That is equal to 0. That's all. No more elements present there, though we travel from this point to here and ends here. Okay. So it is 2 into 10 power 3 I plus 2 into 10 power 3 I minus 2 into 10 power 3 I1, that is equal to 5. This is our first equation. So we can rewrite this as 4 into 10 power 3 I minus 2 into 10 power 3 I1, that is equal to 5. This is actually our first equation. So when you consider the second loop in which we cannot apply the KVL because this current source is available at the periphery. Simply can write it as this I1 is equal to minus of this current value, that is 1 into 10 power minus 3 amperes. As this I1 and the current source are having opposite direction, you have to place a minus sign here. So this is your second equation. Now substitute this second equation in the first equation. So what you get here is 4 into 10 power 3 I minus 2 into 10 power 3 I1. I1 instead of I1 you are going to substitute this value, right? It is minus 1 into 10 power minus 3, that is equal to 5. It is 4 into 10 power 3I minus of minus plus, and this 10 power 3 and 10 power minus 3 get cancelled, so you get this 2, that is equal to 5. That means 4 into 10 power 3 I, that is equal to 5 minus 2, that is nothing but 3. So this I is equal to 3 divided by 4 into 10 power 3. It can be written as is equal to 3 by 4 into 10 power minus 3 amperes. So that is equal to 0.75 milliamps. So this is our answer. So now when you refer your problem, the answer is here. It is 0.7 into 10 power minus 3 amperes or 0.75 milliamps. So this is our answer. Hope you have understood. Thank you. See you again.